Hello friends. Now we will see the Kolhrausch law of independent migration of ions. What is its statement? At infinite dilution, each ion migrates independent of coion and contributes to total molar conductivity of an electrolyte irrespective of the other nature of other ion in which it is associated. Therefore, molar conductivity of an electrolyte is equal to what? This is number of moles of cation into that molar conductivity at zero concentration, this cation, plus number of moles of anion into the molar conductivity of anion at the concentration 0. So, what is lambda raised to 0 to the base negative? So, means what? Molar conductivity at concentration 0, that is of an anion. So, this is here. Now, at infinite dilution, each ion migrates independent of coion, means what? Here, the independent of coion migrates. So, in dilute solution, when electrolyte is dissolved, that time the migration of ion takes place freely. So, that is, for example, the KCl or NaCl. So, what is here? K plus Cl minus, Na plus Cl minus. Such electrolytes in K plus, this is cation, Cl minus anion, Na plus cation, Cl minus anion. So, coion is this, potassium and sodium of these two ions having that coion is what? Cl minus, that is anion. But these ions migrates in solution freely, but each ion again takes parts to develop molar conductivity of that electrolyte. So, therefore, total molar conductivity at zero concentration, so at the infinite dilution, that time the way of that lambda 0, like this, total molar conductivity in this way. So, in another words, in short, how you take this is that Kolhrausch law in short statements. In other words, that molar conductivity at zero concentration, molar conductivity at zero concentration of any electrolyte is the sum of what? Molar conductivity at zero concentration of cation and molar conductivity at zero concentration of anion. This is the another way of that particular statement. Now we will see application of Kolhrausch theory or application of Kolhrausch law. So this is the first. By using Kolhrausch theory, we can calculate the molar conductivity of an electrolyte at zero concentration. We can calculate molar conductivity at zero concentration of an electrolyte. For example, lambda is to 0. This is molar conductivity of potassium chloride KCl is equal to what? The molar conductivity at zero concentration of this cation K plus potassium plus molar conductivity at zero concentration of that is Cl minus chloride ion. So, you have to get this sum, and then from that sum is nothing but molar conductivity of potassium chloride. This is electrolyte. Now, second one is that barium hydroxides. So, same way that the cation of barium plus and that the anion of that hydroxide ion, that is OH minus. So, molar conductivity both of that at zero concentration. If you know this is from this we can calculate easily the molar conductivity of that BOH twice. What is that second? To calculate the molar conductivity at zero concentration, the values, we can calculate these values of that especially weak electrolyte. We know that the molar conductivity at zero concentration of weak electrolytes, we cannot calculate by using that the graphical method, that is extrapolation of that particular in graphical representation. But here by using applying this is that the particular the Kolhrausch law, this is the way of that. Okay. So for example, if you pick up this example, so this is molar conductivity of that lambda base to the 0. To write like this, the way of that. How do you write this of that each and everything? So now we have to see here how to develop this particular the way of that line. Now first of all that we have to know that breakdown of that. So molar conductivity at zero concentration, this way of that. Here like H plus ion plus is that molar conductivity of that Cl minus ion plus molar conductivity at zero concentration of the CS3 COO minus, then again that plus molar conductivity at zero concentration of this Na plus minus molar conductivity at zero concentration of this Na plus minus molar conductivity at zero concentration of this chloride minus ion. If you observe this equation, what is here? The molar conductivity at zero concentration of chloride minus ion negatively charged. This again this is the positive, and then this is molar conductivity of that Na plus, and this is that Na plus. This is getting cancelled. So what is remaining? Only these two terms. Molar conductivity at zero concentration of this cation and of this anion is equal to what? Molar conductivity of this H plus and that molar conductivity of the CS3COO minus. Now what is these two? These two sum is equal to nothing but what? Molar conductivity at zero concentration of CS3COOH. This is the way of that. So it is a weak acid. So by using Kolhrausch law, we can easily calculate that molar conductivity of this acetic acid. It is weak electrolyte. If you know this molar conductivity of that HCl, CS3CONA and NaCl, these are all that the strong electrolytes. Now by knowing these values of this, we can easily calculate the acetic acid values of that particular lambda 0. This value we can easily calculate. Now we will study the molar conductivity and degree of dissociation of weak electrolyte. Now degree of dissociation of weak electrolyte is related to its molar conductivity at given concentration C by the equation. So this equation alpha is equal to lambda to the base C and divided by lambda to the base U, where this term means what? The molar conductivity of a weak electrolyte at given concentration C. This term, the molar conductivity of a weak electrolyte at zero concentration. So the way of that is related to each other. We will study the measurement of conductivity. The conductivity of solution can be determined from the resistance measurement by the Wheatstone bridge. Means what? Those solutions of conductivity we can determine by measuring resistance of that solutions. Okay, ज्या सोल्युशनचं रेजिस्टन्स आपण जर मेजर केलं तर त्या सोल्युशनची आपण कंडक्टिव्हिटी फाइंड करू शकतो बाय द व्हीटस्टोन ब्रिज. नाउ वी विल सी फर्स्ट कंडक्टिव्हिटी सेल्स. मला त्या सोल्युशनचं रेजिस्टन्स मेजरमेंट करण्यासाठी कंडक्टिव्हिटी सेल या ठिकाणी ॲप्लिकेबल आहे and that conductivity cell is used along with that Wheatstone bridge apparatus, Wheatstone bridge, that is particular principle. Now conductivity cell, the way of that. What is that exactly conductivity cell? Look here. It is one glass tube This glass tube consists of two platinum plates which is coated with finely divided that platinum black. Okay. Now this platinum black is achieved by the electrolysis of aqueous solution, the chloroplatinic acids, which is also called as hexachloroplatinic acids. So this is platinum black. Okay. Now this conductivity cell is dipped in solution. The solution, those you have to measure resistance. ज्या सोल्युशन्सचा रेजिस्टन्स आपल्याला आपण मेजर करायचा आहे त्या सोल्युशन मध्ये ही कंडक्टिव्हिटी सेल डिप केली आहे. सो दिस इज द कंडक्टिव्हिटी सेल. Now we will study cell constant means what? Now we know that electrolytic solution conductivity, the conductivity of that electrolytic solution is given by this particular equation. K is equal to 1 upon R into L upon A. So this is resistance. L is the distance between the two electrodes and A is the cross sectional area of that electrode. So for a given cell, ratio of L upon A is a fixed quantity, and this is the ratio of that L upon A is also in short called as that cell constant. So therefore, cell constant, how will you define as? It is the just ratio of distance between these two electrodes divided by cross sectional area of this electrode. Okay. So this is just is nothing but cell constant. Now SI unit of that cell constant is meter inverse, and the another common units is generally convenient, expressed in that particular centimeter inverse. So the way of that the cell constant. Now here, if you see here the first equation, K is equal to 1 upon R into L upon A. Now L upon A is nothing but cell constant. You put down here this term cell constant. So this equation, one equation convert into like this. Therefore K is equal to cell constant upon R. So the cell constant, this is that conductivity of that electrolytic solution and that resistance is related. These three terms related with each other. Means if we know the cell constant, if we know the resistance of that solution, we can easily calculate that the conductivity of that solution, because cell constant is a fixed value. It is a, for a given cell, it will be the fixed quantity, and therefore from this R we can easily calculate that is the conductivity of solution. Now we will study the determination of conductivity consists of three steps. Okay. Now first step is that determination of cell constant. Now in this first stage, determination of cell constant, how do you determine cell constant according to that Wheatstone-Bridge principle? Now cell constant can be determined by using generally the potassium chloride solution. So the potassium chloride solution is generally 1 molar or 0.1 molar or 0.01 molar KCl solution, because its conductivity is known. The potassium chloride solution's conductivity is known at various temperature. Therefore, if you calculate the potassium chloride's the resistance of that solution, we can easily calculate cell constant. म्हणजे cell constant calculate करण्यासाठी, determine करण्यासाठी आपल्याला potassium chloride solutionचं resistance determine करणं गरजेचं आहे, and then know that the conductivity of resistance solution. So by calculating resistance of that potassium chloride solution, we can easily calculate cell constant. Okay, because we know that cell constant is nothing but is equal to the conductivity of that solution and resistance of that solution. Now look here in this diagram. So what is given here? Now this is Wheatstone bridge. Now into this, the Rx is the variable known resistance, D is the current detector, F is that sliding contact, AB is along that particular wire, AC is here under source of alternating current. Now this is that the conductivity cell is joined with this apparatus. Now conductivity cell containing this particular solution. Those solution want to determine the resistance, want to measure the resistance of that solution, and here solution we have taken just that potassium chloride solution, HCl solution. Okay. Now how you calculate, measure the resistance of that solution? So here first is like this. This is the F is the moving contact. This is sliding contact. Okay. So this sliding contact just moves across this wire, AB wire. Now if you go moving on that AB wire, one time you are getting the D detector, there is no current, no flow of current, and that time you are here, that spot, that point is nothing but that is the null point. You understand? So the resistance of this exactly balanced, therefore no current flows, and that is called as the null point, balance point. So by using this Wheatstone bridge principle, the way of that resistance of solution divided by length of AC is equal to what? Variable known resistance divided by length of BC. This is, and therefore resistance of solution, how you calculate, is equal to this length of AC, this is goes to that side, and divided by length of BC into Rx, this is that the known variable known resistance. So the way of that resistance of solution we can easily calculate. Then finally the same constant, how you calculate the same constant is equal to, that is conductivity of that solution, this potassium chloride solution, HCl solution, into resistance of that particular solution. So by using the relation between this cell constant, conductivity and resistance, so cell constant we can easily determine by measuring the resistance of that solution. This is by using that particular Wheatstone bridge principle. So Wheatstone bridge principle is nothing but it is the just ratio of resistance of one edge is exactly equal to the ratio of another edge. So that time in midpoint of that resistance there is no current flows. So that is a null point. So this is just Wheatstone bridge principle. Now we see this point. The determination of conductivity consists of 3 steps. Just we have already seen that the 3 steps. The first step is the determination of cell constant. Learn this point. Cell constant, how you calculate, will determine by using that Wheatstone bridge principle. Now the second point or second step is what? Determination of conductivity of given solution. How you calculate given solution means what here? In first step, cell constant is equal to this conductivity of potassium chloride solution and resistance of that solution. Means here conductivity of potassium chloride solution is known. Do you understand? At various temperature. But if you change solution, if you replace solution, that time how will you calculate that conductivity of that solution? That for that purpose you have to use this particular formula. So what this formula indicates? Cell constant divided by resistance of solution. Cell constant is known. Okay, that is the known value. but you have to determine this resistance of that solution. And resistance of any solution, electrolytic solution, how do you determine? So this is in first step. So you can measure this resistance of solution by using Wheatstone bridge. So this is the way of that conductivity of any given electrolytic solution. The way we can calculate by using this, the equation or relation in these 3 points. Now, third point is what? Calculation of molar conductivity. How do you calculate the molar conductivity? We know that the formula is this: lambda is equal to 1000 A upon C. Okay, 1000 into A upon C. So one point is very important here. In all these equation, all these in formula containing this K, conductivity K, you don't write that is the capital letters K, but you have to write that is small letter K. Here also, here also. Okay. So in this way, if you know the particular conductivity of that solution, the concentration of that solution, we can easily calculate molar conductivity of that solution. Okay, this is way of it. Now look this numerical. A conductivity cell containing 0.01 molar KCl gives at 25 degrees Celsius the resistance of 604 ohms. The same cell containing 0.01 molar AgNO3 silver nitrate gives the resistance of 6530 ohms. Calculate the molar conductivity of 0.001 molar AgNO3. For solving this problem, they have given conductivity of 0.01 molar potassium chloride at 25 degrees Celsius is equal to this. Is equal to what? 0.00141 ohm inverse centimeter inverse. Now, we have to first observe this problem carefully. What they given, what we have to find out. Lastly, they have given like this. What you have to calculate? The molar conductivity of 0.01 molar AgNO3 silver nitrate solutions. You have to find out molar conductivity. Now, what is the molar conductivity formula? We know that this way of it. Now, this molar conductivity related to that conductivity of solution, the concentration. So, you should know that K conductivity also, concentration also. But if you observe this problem carefully, they have given this concentration C, 0.001 concentration. But you don't know K. So, this conductivity K, you have to find out using another equation, and for that purpose you have to see in detail. Now first step, cell constant. How do you calculate? Cell constant is equal to this potassium chloride, that is conductivity K, into resistance of KCl solution. Now they are given both of these values from this to here, the way of that particular value. This is resistance, okay, and that the particular the conductivity of that 0.141. Now using these two values, we are getting this 0.852 centimeter inverse. So this is that cell constant. Okay. Now the conductivity of AgNO3, how do you calculate? The K is equal to cell constant divided by R. Therefore 0.852 divided by R, this is that value. To calculate the value, I put down here, and that is the given. This is the R resistance of that AgNO3, 6530 ohm. If you calculate this, you are getting 1.3 into 10 raised to minus 4 ohm inverse centimeter inverse. And then finally, the third, the molar conductivity, we can calculate now using this formula. Okay, so K, this is 1.3. Just you have calculated. Put down here this value. And then the way of the concentration C, which is given in that particular problem, 0.001 molar, and the way lastly getting this particular value of that molar conductivity of silver nitrate solution. Okay.